Electricity is the greatest gift of science to mankind. We have reached a point of our civilization where electricity is used for all purposes. However, in recent times, construction of new, large power-generating plants is not keeping pace with growing electricity demand. And at the same time, customer demand for even more highly reliable power is growing day by day. In centralized power generation concept, the generated power in remote locations, while being transmitted and distributed, incurs a loss of 23%. Moreover, the cost of the network upgrades required to enable today's power system to deliver the level of reliability being demanded is far in excess of what society has so far been willing to bear. MicroGrid provides an appealing solution to these problems. But what is this microgrid? MicroGrid is basically a self-contained electrical ecosystem. Power is produced, distributed, consumed, monitored, and managed on a local scale. MicroGrid is an integrated energy system network consisting of distributed generation sources and multiple electrical loads, and all meters operating as a single autonomous grid, either in parallel to or islanded from the existing utility power grid. The most advanced technological components that make up microgrids are all forms of distributed generation resources like solar, wind, fuel cells, biomass, hydrogen, and clean-burning, renewable natural gas gensets. These on-site generation units are increasingly being fueled by renewable resources such as the sun and the wind. The other key hardware technology that will enable attractive microgrid value propositions will be cost-competitive microstorage. Battery technologies are advancing rapidly, like lithium-ion, zinc, bromine, flywheel technology, etc. Microgrid control systems allow all of the diverse components that make up the microgrid to work in concert to preserve voltage and frequency, and perhaps protect critical loads. When in islanding mode, microgrid control systems intentionally reduce the frequency of an island at microgrid to coordinate the power balance between distributed generation resources and corresponding loads, as well as storage devices. The benefits of microgrid include improved efficiency, reliability, and consistency in distribution of electricity. Effective management and utilization of renewable energy at the microgrid level helps reduce emission of greenhouse gases and other pollutants, thereby safeguarding the environment. Isolated microgrids can also be used in remote areas and geographical islands where grid connectivity is an issue. Providing an integrated solution for reliable power supply and integration of renewable energy resources, even in remote areas. Cal MicroGrids, with his expertise and hands-on experience in renewable power generation and distribution, have the capacity to provide the full turnkey solution for microgrids. Cal MicroGrids, helping California industry with reliable, resilient, renewable power.